Hi boys and girls, welcome to my YouTube channel. So today we are going to discuss this last portion of your Unit 3. This is the last portion of your Unit 3 in signals and systems. Analysis of continuous time signals. We have what we call continuous time signals. We also have what we call discrete time signals. In today's class, we are going to focus on the analysis of what? Of continuous time signals. Okay, suppose you have an input signal. You can feed the input signal to the what? To the system. What will happen? The system is going to perform some operations. The system is going to perform some operations on the what? On the input signal. And we are going to have the what? We are going to have the output. Okay, so what is a system? A system is nothing but a device which performs some operation on the what? On the input signal to produce the what? To produce the output signal. Okay, so this is the system. This is the input to the what? To the system. And this is the output of the what? Of the system. Suppose my input is x of t, my output is y of what? Of t. This is my system. I say the system is nothing but a what? A device. And this device is going to perform some operations on this input, and I'm going to have this what? I'm going to have this output. Suppose x of t is given, which is the input. Suppose y of t is given, which is the output. If the input is given and if the output is given, you should be able to tell the effect of this system to the input. You should be able to tell the operations of this what? Of this system. Okay, for example, let's say x of t is given as the input. Suppose this is the input. X of t is the what? Is the input. And the output is also given. This y of t is nothing but dx of t by dt. So this is the input and this is the what? This is the output. Suppose this is my case. This is the input and this is the output. Now I want to tell, is this system, what type of a system is this one? Is this an integrator? Is this an addition system? Is this a multiplier? Or is this a differentiator? Something like that. Okay, you should be able to tell. If you check, this output is the derivative of the input. The output is the derivative of the what? Of the input. Which means the system in this case is nothing but what? Is nothing but a differentiator. You can easily tell that the system is a differentiator. Okay, suppose your input again is x of t. And suppose your output, this y of t, is the integral of x of t with respect to what? With respect to t. Okay, the input is given, the output is given. This is the case. In this case, you can easily tell me the system is nothing but a what? An integrator. Why? Because the output is the integral of the what? Of the input. That's why we are calling this system a what? An integrator. Okay, so you should be able to tell the relationship between the input and the output of a system. You should be able to tell this relationship. Very, very important. So we are going to analyze the continuous time signals in this class using what we call Laplace transform. Okay, we are going to use Laplace transform. Is this clear? Okay, if it's clear, let's move on to the next part. We have what we call the step response, impulse response, and the output response of the what? Of the system. We have what we call the step response, the output response, and the what? And the impulse response. So see, this step response is nothing but the response of a system, the response of a system. If the input signal is a unit step signal. So I said x of t is my input signal. So if this x of t is equal to u of t, then you are going to calculate what we call the step response of a system. So the step response is nothing but the response of a system if the input signal is a unit step signal. This output response is the response of a system, yes, the response of a system. Okay, if the input signal, or you can say if the input signal is neither a step signal, a unit step signal, nor an impulse signal, So in this case, the input signal is not a step signal. The input signal again is not an impulse signal. Suppose this x of t is equal to some function 2e to the power negative 3 what? Negative 3t. Suppose x of t is equal to 2e to the power negative 3t. It means what? In this case, you are going to calculate the output response. Then it is called the impulse response. This is the response of a system, the response of a system. If the input signal is a what? Is an impulse signal. That is del of what? T. So in this case, I'm saying x of t is equal to what? Is equal to del of t. X of t is equal to del of t. This is very, very important. So this step response is nothing but h of what? This is nothing but y of t. Y of t. You'll be finding y of t. Again, output response, you'll be finding y of what? Y of t. Then the impulse response, you will be finding what? The impulse response, you will be finding h of t. This is very important. So impulse response is nothing but h of t. The output response is nothing but y of t. The step response is nothing but y of t. Now we would like to discuss the Laplace transform. How are we going to apply the Laplace transform in this case? So see, you can take the Laplace transform of the input signals. You can also take the Laplace transform of the output signal. Okay, like the Laplace transform of x of t, the Laplace transform. Suppose you have differentiated this, so the Laplace transform of this one by dt. So this is telling me how the input signal is varying with what? Is varying with time. The Laplace transform of d squared x of what? T by dt what? Dt squared. So this is equal to, if you take the Laplace transform of this small letter x becomes capital letter x, and this small letter t, it becomes small letter s. Here it becomes what? It becomes s, x of what? S minus x of 0. Okay, here if you take the Laplace transform of this, it becomes s squared x of what? S minus what? Minus s x of what? 0 minus x bar 0. Okay, so this is the Laplace transform. You can also find the Laplace transform of d power 3x of t by dt power 3. Okay, I'm going to consider this side. Okay, see, they are going to give you a problem whereby in some cases the value of x of 0 is given. In some cases the value of x of 0 is given. The value of x bar of 0 is also given. Okay, if the value of x of 0, the value of x bar of 0 is given, it means you have to substitute accordingly. Otherwise, if x of 0 and x bar of 0 is not given, it means what? These are the initial conditions. You substitute this with 0, you substitute this with 0, you substitute this with what? With the 0. Okay, if the values are not given, we are going to place 0 here, we are going to place 0 here, we are going to put 0 here. Okay, if the values are given, you have to substitute accordingly. So these are the initial conditions. Remember, Laplace transform is all about converting the time domain to what? Time domain to S domain. See, it's, in some cases it's very difficult to what? To analyze a signal in the time domain. So we have to convert it from the time domain to the S domain so that the analysis would what? Will be simple for us. Okay, you can also take the Laplace of the output. The Laplace transform of y of t, the Laplace transform dy of t by dt, the Laplace transform d squared y of t by dt squared. Okay, like this. So here, if you take the Laplace transform of y of t, this small letter y will become what? Capital letter y, and this small letter t will become small letter s. Here, you are going to have what? S, y of what? Of s minus y of what? Of 0. Here you are going to have s squared, y of s minus s, y of 0 minus y bar of what? Of 0. Okay, if y of 0 is given, you have to substitute accordingly. If y bar of 0 is given, you have to substitute accordingly. Okay. Otherwise, you have to substitute these values with what? With the zeros. These are the initial what? These are the initial conditions. So we are going to use the Laplace transform in the analysis of what? Of continuous time signals. Okay, I will see you in the next class whereby we will be doing problems related to finding the step response, finding the system function, finding the output response, finding the impulse response. Thank you very much. Have a good day.